Okay, so we were talking about how this graph here isn't giving us an accurate representation of what the function looks like. Now it might be different on your calculators depending on the firmware you have and the type of calculator you have. Sometimes they will graph it right and sometimes they won't, but the idea is this. No calculator will graph every function 100% correctly all of the time. And we have to be smart enough about how we use the calculator to know when we need to look deeper or to know when the graph doesn't necessarily match what we're looking at. So the function that we were graphing was sine of x over x, and we think that this function has what's called a discontinuity at 0 because we can't have division by 0. And if we look at the graph of the function, it appears to be fine. One way that we could look at what's going on is we could look at the table. So we press second table here, and it's going to bring us into the table, and we can see that there is in fact an error or a discontinuity at x equals 0. A question we try to answer in calculus is this: what is the limit as x approaches 0 of this function? Meaning, we know that the function doesn't have an actual value at x, but what value is it approaching as it gets close to 0? And we can use this table to help us out. Now, right now, it looks like the function is 0.841. But if we look at the graph in trace, it looks like the function is, and we can actually enter a value here. So I could say 0, and it'll say, oh, well, what's x equals 0? And it'll tell me, oh, y is undefined. It doesn't give me any value. But I could do 0.000001. I could get really close to 0, and it's going to tell me, oh, y is pretty close to 1. Or I could say 0.001, get a little bit farther away from 0, and you can see what's going on there. So we can, that's a very repetitive process, going like, oh, 1.01, and we can see, as we move the cursor farther away from 0, we can see the y value getting farther away from 1. Or when we move the cursor close to 0, we can get the y value closer to 1. We can do that in the table more quickly by looking at the table, and then we can do table set. So table set's up here, second table set. We can tell it where we want it to start. So let's have it start at 0. And we want to move by small amounts. So let's say we want to move by 0.01. And we'll go back and look at the table and see what happens. So this is what I was talking about. The function is still undefined at 0, but by having the table move by very tiny amounts closer and closer to 0 on either side, we can see that the function is getting closer and closer to having a y value of 1. That's an idea of a limit. We'll talk more about that later, but that's how the table can help you verify the limit of a complicated function. In this case, taking the limit of sine x over x is not very easy. All right. Next, let's go back to our graph, and we're going to turn off our trig function. We're going to turn back on the parabola and the line. And we're going to graph these as regular lines now. So we'll get the regular option here. You can do thick or thin lines, it doesn't really matter. Go down, do a thick line there. Okay, so we're going to graph those. We're going to need to do a different viewing window from the trig viewing window. So we'll go Z standard. I want to show you how to use a couple of different functions now for analyzing systems of equations. Here our system is a line and a parabola. In the notes, this is under this section here, finding intersection points, example 5. So if you want extra practice with what we're about to do, then this is a good place to read. Anyway, so we can go to Calc, and that's going to give us a bunch of different calculations we can do based on the graph. Let's say we want to find the minimum value that that parabola has. So we can go to minimum. We need to select the correct graph. Right now it's selecting the line, but we wanted the parabola. So we're going to press the arrow over, or actually, up, sorry. We're going to press the up arrow or the down arrow to switch graphs. We're going to switch to the parabola, and it's saying left bound. What the calculator needs you to do is it needs you to tell it a small area around where the minimum is. So you have to be smart enough to know where the minimum is for the calculator to tell you exactly what the minimum is. So the left bound would be, it just wants the cursor slightly to the left of where you think the answer is. And the right bound, it wants the cursor slightly to, slightly to the right of where you think the answer is. It's freaking out on me. And then it asks for a guess. So you're going to move the cursor back to where you think the answer is. Press enter one more time, and that's going to give us our minimum. Now, take a look at this. For the x value, it's telling us 1.46 times 10 to the negative 6th. That's a number that's really close to 0. Any answer you get from the graph is estimated. And we have to be smart enough to know that this minimum is actually at 0. This is not the correct answer here. The calculator is estimating the answer that the minimum occurs at x equals this number, but we know the minimum actually occurs at 0, that this number is a little bit of error that the calculator has had trying to find the minimum. Okay? We can reduce error by zooming in on the graph. So we could zoom in and it would give us a more accurate answer. But in this case, what we were after was the value of the minimum value of the function, which is -5, and we can see that right there. Now, let's say that I asked you to find the square of the minimum value of the function. What we could do is, now that we've found the minimum, we can quit out and we can say we want the square of the minimum value, which was stored in y, and we get 25. Okay, so again, no need to copy things down. And again, if we wanted to look at where the minimum happened, which was the x value, we can see that's what that was. And again, that number is really, really close to 0. So a little bit of rounding. Okay, now let's go back to the graph. Let's say that we want to find our points of intersection. Here we can see there's 2 points of intersection. So we're going to have to do this process twice. Calculator can only give us 1 point of intersection at a time. So we're going to say intersect. We need to tell it the 2 graphs that we want to know the intersection of. So we'll select the line and press enter, and we'll select the parabola and press enter. And then it wants us to guess. And the reason for this is we need to get the cursor close enough to the intersection point that it can pick the one we want to know. So there's 2 here, and it can only give us 1. So we're going to put the cursor close to the intersection, press enter, and there we go. That's the intersection. And again, if I need these values, I can go back to the home screen and I can get those values directly from the x or the y variable. That was our y location for that intersection point. Okay, let's try another thing. So we can go to the graph. Commonly in parabolas, we want to locate zeros. So one thing that we could do is we could go to Calc and we could do 0. And again, it wants a left, oh man, it wants a left bound and a right bound. And we wanted the parabola. I've selected the line. So let's go back to Calc, 0, Let's select the parabola. There we go. And we're going to move down towards the 0. Press enter. Oh, we wanted the left bound and the right bound. Try it one more time. 0. We're going to move our cursor slightly to the left of the 0, slightly to the right of the 0. Give it our guess. And there we go. So y is equal to 0. Here it got it right. There wasn't any error there. And we get our estimated. Remember, all answers from the graph are going to be approximated answers. So the answer is approximately 2.236068. And that's about as much precision as our calculator can give us. All right, let's go back to the graph and let's turn off the line so we can just see the parabola. Let's say that you had a question that asked, at what values for x does the parabola have a y value of 5? Well, that's not as easy to answer graphically, but there's a trick that we could do. We can make another line that always has the value 5 and graph it. Now we can visually see the two places that the parabola has a value of 5 along the y-axis. And we can use our skill from before with the intersection to locate those two places. We'd have to do this process twice. So this is our first curve, and then the line, and then our intersection is right about there. And there we go. So it gives us our x value for when the parabola has a value of 5. And we could do it again for the other side. So that's a little trick for answering questions like that, where we're not actually finding a 0, we're finding some other y value. And that's going to be it for today. You guys will notice in the OneNote that there's a problem set page here. And basically that's going to be problems for you guys to work on in class Wednesday and Thursday to practice what you've just watched. When you get done with that problem set, there'll be another video for some more practice with calculator usage for Friday.